This video is part 3 in a series of videos about how to distribute one object on the surface of arbitrary triangle meshes using Geometry Script in UE 5.0. So in the first part, I showed how to do this for a single mesh by basically making a copy of the mesh and building a BVH for it. In part 2, we extended that to be able to distribute on multiple meshes in the scene. And the way we did that was by making a copy of the scene meshes and then building a BVH for that. Now, the one drawback of this method is that to update the boxes, we also made a new copy of the scene and rebuilt the BVH every frame, even though the source objects aren't changing. Now, in this example with 2 bunnies, it's not so bad. The performance is okay. But if we go over here where we have 10 of those bunnies, we can see that things start to bog down and it's no longer interactive. So the overhead here isn't distributing the boxes. It's making the copies of the meshes and building the BVH. So what we're going to do is we're going to take the blueprint we built in that video and separate it out into 2 parts to solve that problem. So I'm going to open a different level here. And here's, again, a scene with 2 bunnies. So essentially what we did is we put the part that makes the mesh copies and builds a BVH into one blueprint. That's going to be BP World Cache. And then we made a second blueprint to do the object distributing. So the World Cache blueprint is just a cut and paste of the full blueprint from last time. So I have a set of target actors, which are the actors we want to distribute stuff on. We have a Raycast mesh and a BVH for that mesh. This is the target mesh that's a copy of all those objects, and a bounding box. And instead of doing it in our event graph, in the rebuild generated mesh event, which is empty in this blueprint, it has no mesh, we're just using it kind of as a utility, we have this function update world cache, and that function is marked as call in editor. And what that means is that when we select that in the level, we see that there's a button here, update world cache. And I'll just quickly browse through there. So it allocates the compute mesh for the Raycast mesh and then loops over the actors and does copy mesh from component in world space and appends those, and then it builds a BVH and it gets the bounding box. So that's the same as last time. And then this mesh also has some other public functions. One is called find ray intersection. So that just does the Raycast part, but instead of it being called inline, we exposed a function that does it. And returns the hit position in normal. So this is a kind of interface that other blueprints can call, and I'll show that. And then another function to get the bounding box, which just returns the bounding box. And then our Raycasting blueprint is separate and essentially works the same way, where it's in the rebuild generated mesh. We're going to, we take in, instead of taking in a list of actors, we take in one of those world cache blueprints as our target. And so essentially we're going to do the same for loop that we did before, where we're going to make a random point on the bounding box, which we also get from the world cache, and then we're going to call the find ray intersection function on that world cache, and then we're going to append a box at that location. So this is all the same. I've added a little bit here if you're pausing and looking at the nodes, just to print some debug output about number of hits and things like that. That's why it's slightly different. Okay, so how do we use these 2 things? So I've got my world cache blueprint in the level, so that's just placed anywhere. It doesn't matter because it doesn't actually have any geometry. And I've set up my target actors as the 2 bunnies, and I'm going to click this button, update world cache, and that now has built the cache object, which is essentially the copy of the scene and a BVH. You can't see it, but it's there inside that blueprint. And now the Raycast BVH, if I drag on it, you can see it distributes the boxes. And it's maybe hard to tell in the video, but this is even now it's more performant than the other one was. I can go up, to 2,000 here, where even going to 1,000 in the other one started to chug. So one thing I'll just note is that nothing here updates automatically. That's just the nature of Blueprint. So if I want to move this object, right, the scattered points aren't going to update, but also the cache doesn't update. So if I go back and change this, it's still, the cache is sort of out of date now, so I have to go update it. And then I have to go to this scattering blueprint, and then it will be in the right position. So you could do things like set up editor utility actions, or maybe some kind of automation to do that if you were using this in a real project, but in this example I haven't done it. So the big advantage of doing this is that now you can do this process on much larger triangle counts, and it still remains interactive. So I'm going to load this other map, which has this huge mesh in it that is 2 million triangles. So I'm going to go to my world cache. I've got that there, the bunny and the canyon. I'm going to click Update World Cache. This is going to take a bit of time. So making the copy, building the BVH, this is going to take a few seconds. Now there, it's done. So now if I go to the Raycaster blueprint and drag the boxes, you see it's essentially the same speed as it was for the two bunnies, even though now I'm using 2 million triangle target mesh. Now I will say I wouldn't recommend trying to do this across, say, like 10 of these 2 million triangle meshes. As you get up to more and more millions, it's going to get increasingly slower, but it is an effective way, say, to distribute something on a single large cliff like this. If you want to do many high resolution objects, I would suggest making lower res proxy meshes that maybe are hidden for this process. But that's the example. Thanks for watching.